Ladies and gentlemen, hello, and thank you for joining me today. The subject of my talk today is about artificial intelligence. Artificial intelligence is 1,000 times smarter than we are and can digest information 1,000,000 times more than we can. In fact, the field of artificial intelligence has been moving at an extremely fast pace in the last few years. But do you know how AI will change your career? Well, I have some ideas. I'm Ahmed El Sarafi. I'm a radiologist, both in the academic and clinical arenas. I'm also the CEO of an AI focused company. Well, that means a couple of things. First, it means I'm kind of old, but that's so evident in the photo I have in front of you with the white hair. Second, it means that I'm thoroughly immersed in the world of imaging and technology. I'm getting first-hand exposure to problems encountered in the daily work of radiologists, people like you. But in the meantime, I think I'm privileged in getting to experience new systems and applications that promise to sort such problems out. It has become so obviously clear that AI not only will profoundly impact the practice of imaging, but will totally change it. That's why I think it's important to discuss the different concepts of AI. With this in mind, I welcome you to my lecture aiming at providing an introduction to AI. For a long time, we thought of artificial intelligence as an abstract idea that belongs to the future, that will lead to something terrible like war against killer robots, something akin to the short clip from the Terminator movie that I've seen you. Well, it might disappoint you that this is not the AI I will be talking about today. We're slowly realizing that AI is a very different beast altogether. AI has already sneaked into our lives, penetrating its every layer almost invisibly. AI capable of creating photorealistic faces, such as the ones you see on the screen in front of you. These faces are impossible to differentiate from real faces. This is the kind of AI I'm going to talk to you about. So the agenda for my presentation today would cover definition, types, and history of AI. I'll talk about the impact of AI in our daily life. I will discuss the principles of AI. And of course, I will be mentioning applications of AI in healthcare. Objectives being to have a clear picture of what AI is, but also of what it isn't. I'll explain how AI works, and we will explore the current status and future of AI in healthcare. I guarantee you that after the next 30 or so minutes, you will have a clear picture of what AI is, how it works, where it stands today, what it's going to be, and what it all means for the world of medicine. So, what is artificial intelligence? Well, there's a lot of confused ideas about this, but the answer is very simple. AI is enabling computers to mimic human intelligence using software that writes and updates itself. We normally tend to think of software as stuff that we've created and we wrote, and the machines do what we tell them to do. Well, basically, we own it. Well, this is no longer true. It writes itself at speeds that we can hardly comprehend. I'm talking about AI. And we cannot take it apart again and figure out what it's done. It writes independently, autonomously, and it develops its own way of thinking. And there are dangers associated with that. A lot of people ask, when is artificial intelligence going to be smarter than us people? Well, some people say 50 years, 30 years, 20 years. I believe in some aspects, at least, it has surpassed us. So as we stand, we have the narrow AI, where computers are immensely powerful in conducting one task, much better than we can do. But in the future, we can expect to get into the era of general AI where human level intelligence across the board will be achieved by computers. Doesn't worry me, but what really worries me is getting to the era of the super AI, where computers are going to be smarter than humans. And this is where the danger lurks. Now, history of artificial intelligence has been in the making for a long time. Although it's a buzzword today, but it's not new by any means. The history has been rich and witnessed exciting breakthroughs. In fact, the idea of artificial intelligence has been around since the very earliest days of computing. It's a grand project to build machines that are intelligent, and that has captivated computer scientists ever since. In fact, even before the 1920s, that's 100 years ago, mathematicians have laid the groundwork for fundamental machine learning technologies. However, it's in 1950 when the first computers came about. That's when Alan Turing attempted to describe artificial intelligence and question whether or not machines have the capacity to learn. 1951, Marvin Minsky successfully built the first artificial neural network, attempting to simulate the way human brains work. 1956 saw the coining of the term artificial intelligence by John McCarthy at the Dartmouth Conference. 1963 is important for us radiologists because this is the year when Ludwig published the first paper on using computers to diagnose primary bone tumors. He did that by calculating the probability of a result based on presence of a particular finding. 2012 was really the groundbreaking year for artificial intelligence when Geoffrey Hinton's AlexNet became a milestone in image recognition using deep learning techniques. That year he won the ImageNet challenge, and I'll come back to the ImageNet challenge later on, or probably in my next lecture. Now, I said we are engaging with artificial intelligence in ways that we might not be even aware of in our daily life. When you wake up in the morning and you reach for your mobile phone to catch up on your messages or emails or social media, that face recognition that opens up your phone is AI enabled. Your social media, they work through AI to present to you what is perceived as relevant. Your Google search is tailored to your needs through a profile that Google has for you that was built through artificial intelligence. Aviation was one of the very first industries to utilize AI in their co-pilot systems. Google Maps and Uber use AI to recommend the best route for your journey. Voice recognition, natural language processing, these are techniques to make use of your natural language as commands for computers. Banking security is all based on AI now. Netflix, the way they offer you movies to watch based on your preferences is based on AI. Amazon, they've taken great strides in utilizing AI. They can actually predict what you might want in the future, but not only predict what you might want in the future, they can actually predict when you will want it. So these are all examples of how AI has penetrated our lives. And I think a lot of us are just not aware of that. Now let's look at Facebook. Facebook users upload on the order of 2 billion photos per day, and each one of those 2 billion photos goes through 4 convolution nets within 2 seconds of being uploaded. One of them just tags images, all kinds of stuff in images. Is it a wedding, a party, a birthday party, or is it a landscape or an indoor scene, whatever it might be? Is there a dog in there? What kind of breed it is? Is it a sailboat? There are a few thousand tags like this that are recognized. The second net is concerned with face recognition, and it automatically tags your friends. The third generates captions. What sort of an image description is best befitting of that photo? And the fourth net basically detects objectionable content, things like violence or pornography. So these are the 4 nets that Facebook actually uses to filter through, to screen all these photos it gets uploaded on. Now let's get technical and look at how artificial intelligence works. Now, to understand how artificial intelligence works, you've got to understand how traditional computing works. In traditional computing, computers follow instructions, they're programs. And these programs are handcrafted by us, by human beings, and that's how they appear smart. They're not really smart, they're made to be smart through handcrafted programs made by humans, and they just follow our instructions. But how do you make computers smart? How do you make them like human? We humans, we learn from experience, and that's how we become intelligent. And if we could make computers learn and experience their environment, they can be smart. Now, the way we do it is by exposing the computers to experience, which is data. And if you want them to learn something, you show them examples of this, and it will learn how to do it in the future. Now, artificial intelligence encompasses both machine learning and deep learning, which are really subsets of artificial intelligence that aid it by providing a set of algorithms and neural networks to solve data-driven problems. I have to tell you that the terms artificial intelligence, machine learning, and deep learning are used interchangeably. They're not really exactly the same thing, but we tend to use them interchangeably to mean the same thing. Now, let's look at the AI landscape. Now, a fairly standard introduction to AI looks like this hierarchy, where artificial intelligence is a very broad area encompassing the broadest concept of getting computers to behave intelligently. It encompasses image recognition, speech recognition, natural language processing, translation, decision making, that's expert systems, and robotics. But a specific subgroup of that is machine learning, which uses training methods to sequentially improve the performance of machines so they can do difficult tasks. That's to say, they essentially learn in a way somewhat analogous to how people learn. Now, another subset of machine learning is deep learning, where using multi-layered neural networks to tackle vast amount of data is utilized. Now, traditional computers. This is where decision making is built directly into a program made of thousands of manually created lines of code. When we write a traditional program, we usually build the decision making directly into the program. So, if we wanted to develop a program that could recognize my face, for example, we would tell it look for the white hair, for the brown eyes, for the pointing nose, for the, I don't know, glasses, and the computers would look for that. So we would have the images or the data presented to the program, such as here, and the computer analyzes those and brings out the result. Let's look at an example. Let's say we have our data as the two numbers 3 and 3, 2 digits. And we actually present these 2 digits to a program that adds. What does a computer do? It actually churns out an answer. 6. It's that simple. We do not ask the computer to do anything, but activate the program to analyze the data. And that's exactly what it did. Let's look at traditional computing in a more graphical manner, where you would present an image which has a dog and a cat to a computer program that can identify cat features. And what does a computer do? It looks for the cat features, the triangular ears, the nose, the fur, the tail, the paws, the whiskers, and it actually marks out the part of the image that has these features. This is all conventional or traditional computing. But what about machine learning? Machine learning is different. It's actually a two-step process where an agent is presented with labeled data that would create a model capable of identifying data with similar features in the future. So what we have here is the learning phase, where the sample data is presented with the expected results, and a computer comes up with the model that would be able to identify such results in the future. So when a new data is presented to the model or the program that was created from the previous step, the computer comes out with the result. Let's look at an example. In the learning phase of machine learning, data together with the answer are presented to the computer, and the computer is asked to build a program that would bring these answers. And the computer comes with a program that's addition, because that's a program that would answer 6 when presented with the data 3 and 3. Now, second phase is actually the reasoning phase. So we will take that program that we've had the system create and present it with the data, new data. So the program that was created was was addition, and the data was 2, 3, 4, and 5, 6, and we asked the computer to work out the result, and the answer is 20. Now, you've got to understand that this part of the machine learning application is traditional computing. It's only the first part where the machine had to create the program. Now, let's look at a more graphical example of this. The learning phase, the data is cat pictures. So we're going to present the computer with loads of cat pictures, and we're going to tell the computer these are cats. The answer is cats. Now, I want you to create a program that would identify cats when presented to it. So the system comes up with a program that can identify cat features such as whiskers, ears, tails, furs, paws, and claws. Remember, the system does this all on its own, no human intervention. Now we take this program to the second phase, the reasoning phase. So that program is presented with a pet picture, a cat in this example, and it looks for the features. And if it identifies the features, it comes out with the answer, which is cat. But what happens if you present it with a dog picture? Well, has never seen a dog, doesn't really know what it is, but what it knows is that it's not a cat. So it will tell you not cat. So that's very simply how machine learning works. Now, it looks also simple, so easy. But why now? Well, it took almost a century to bring progress to the level that we could practically achieve working artificial intelligence. The reason is that many different fields had to come together and make advances. We needed lots of data. We didn't have access to lots of data before internet. Now we do. Computer power was not really there. Now with very fast CPUs, GPUs, TPUs, we have that power. But also, we didn't have the machine learning and deep learning algorithms advanced to a very high level until very recently. So, these are the reasons that it took so long for artificial intelligence, machine learning to become a reality. But there's one more reason: money. There's so much money to be made developing artificial intelligence applications because the world depends on it now. So this is another reason why there's so much work and there's so much advance in artificial intelligence. Okay, moving on. What are the AI applications in healthcare? But first, let's look at why we need applications such as AI applications in healthcare. We're challenged. Healthcare is challenged. It's challenged by shortage in healthcare professionals. And this map actually depicts the number of doctors per 1,000 population 5 years, 6 years ago. Now you will see that only small parts of the world have a density of 5 doctors per 1,000 population. Our part of the world, only 1 doctor per 1,000 population. That's really low. And what that spells is shortage of 7.2 million healthcare professionals today. By 2030, that shortage is going to be 18 million. But to add insult to injury, by 2050, there are going to be 20 billion population over the age of 60 years. Now, what that means is that huge amount of population over the age of 60 are coming to the healthcare market with their chronic disease. That's another load to think about. So, healthcare is challenged, but so are healthcare professionals. They're challenged by the growing data volume and complexity, and you could see in this graph how data has increased exponentially over the years. Medical images making a good chunk of that data. Now, for some numbers, medical data doubles every 73 days. Just think of it. Every 2.5 months, medical data doubles. For a run-of-the-mill GP, average doctor, to keep up with all the latest in his field, I'm talking about a GP, not a specialist, they need to read continuously for 29 hours a day. I don't think anyone can do that. What that means is that 45% of medicine is not evidence-based, simply because doctors cannot keep up with the latest developments in healthcare. So, any hope? Yes, artificial intelligence. Artificial intelligence has come up with the promise of helping meet these challenges. Now, to say that AI is hot is an underestimate. This is a graph of AI publications that you can get off PubMed since 1992. And you can see that this went from less than 500 to 20,000 over 30 years. This is an explosive field, and imaging is contributing significantly to its exponential growth. What AI promises to bring to the field of healthcare, its value proposition is to improve productivity, increase quality, have more accurate diagnosis, and better treatments. So it will achieve this through reducing human error, reducing repetitive and tedious tasks, provide support tools, improving accuracy, and allowing for greater access to healthcare. In short, it will automate, accelerate, standardize, and simplify healthcare processes to improve delivery of patient care. Now, let's look at some fields where AI is having profound impact. Histopathology, one of the perceptual disciplines in healthcare, allows us to extract more information from digital slides than we can manually. We can detect malaria, anemia, leukemias, cancers much faster, much more accurately than we used to do in the old days. Ophthalmology is another field that has benefited from AI, especially in the detection of diabetic retinopathy, where we have applications that can scan retinal images more accurately than an ophthalmologist can, and detect early changes associated with diabetic retinopathy. Why is this important? Because we have 400 million people worldwide who are diabetics and who are liable to develop diabetic retinopathy. Now, half the patients with retinopathy would suffer death before even being recognized. So that's something to think about. Dermatology has moved on from using the hand lens to using cameras even ordinary phone cameras to detect melanomas, squamous cell, and basal cell carcinomas very accurately. Cardiology, now we can read ECGs and auto-detect myocardial infarction using AI algorithms. We can measure ejection fractions automatically in echocardiography, and we could autocardiac segment MRIs using artificial intelligence almost instantaneously. Endoscopy is another field that has benefited enormously from artificial intelligence, where we can automatically detect polyps, for example, in this colonoscope. But let's look at the movie. This is something that's done real time. So as the gastroenterologist advances the endoscope, the system would alert to the presence of a lesion, such as here. But it's not only the obvious lesions that are detected, even the less obvious and the ominous lesions can be seen. Neurology, very much like ECG reading, we can read EEG tracings. Now, this is important because for anyone who has seen EEG tracings, these could be miles long. Dentistry is another field that has benefited from AI, with the AI-powered toothbrush that tracks hygiene of the mouth, chair-side cameras that could provide face recognition and vision aids to the dentist, as well as imaging interpretation from panoramic and cone beam CT images, as in here. Mental health has not been forgotten. In fact, we have intelligence applications to predict and diagnose depression, things like chatbots, computer interactions, Facebook. So in closing, I want to say that AI is here to stay, and it will change. I'll change this. It has actually changed the practice of medicine. Physicians do not need to turn into computer scientists, but need to understand AI enough to be able to converse with data scientists. Data scientists are going to be our colleagues, our close colleagues, very soon. So we need to be ready to speak their language, or at least understand them. And as such, I really urge all healthcare professionals to embrace AI and not fear it. With this, I've come to the end of my presentation, and thank you very much.